Okay. Tonight we're very fortunate to have a software guru. Our speaker is the part of the only couple with his wife Anna that has won a Willison Memorial Award. Please join me in welcoming Alex Martelli.
Yeah, actually, I'd like to clarify that each of us has separately several years given, and she's the first woman honored with the award, although I'm sure not the last. Get involved in the community, get involved in organizing. That's the most precious gift you can give back to Python, which has given all of us so much. All right, so let's start by checking some cultural assumptions, get the temperature of the room, as they say. Who is in agreement with this general attitude that everybody should always be striving for perfection at all times? So settling for a software release that's anywhere below perfect is a regretful compromise. Who agrees? Okay.
If it's worth doing right.
Or, alternatively, would you rather keep it simple, just good enough? Lunch early, lunch often, get plenty of feedback, listen, and iteratively improve, enhance, refactor. Oh, good. So my talk is done because you already fully agree with all I have to say. And so, well, there's one gentleman who I need to convince that good enough is good enough. Anyway, preaching to the choir is always the easiest job for any preacher. So let's start with a 1989 paper. Actually, central part, the light relief within a very serious keynote at a Lisp conference about the where was Lisp going, what future did it have, and so on. Smack in the middle, Gabriel, the keynote speaker, presented a more general idea that there's two approaches to writing software. One he dubbed the New Jersey approach, which may sound insulting to some of us, but he actually called it worse is better, which is definitely doesn't sound very positive. The other one he called the MIT Stanford approach, and he also dubbed it the right thing. So no bias there. Specifically, so the rest of his keynote is essentially forgotten, including in the Lisp community, but these 15, 20 minutes in the middle of it sparked years of debate to ensure that Mr. Gabriel wrote on both sides of the debate, and to avoid giving the impression that he was debating himself, as he was, he wrote one side of the argument under the interesting pseudonym of Nicky Ben Bourbaki. Anyway, he argued both sides of the issue very convincingly. But let's just summarize many years of debate. More or less every software developer can agree what you want is some combination of four things out of your software. You want simplicity. Nobody deliberately wants complicated stuff, right? Correctness. Nobody sets out to do wrong. Consistency, again, not inconsistent. And completeness. You want to have gaping holes, missing features, and so on. So far, so pretty uncontroversial. The point is that even within, if we all agree these are four important dimensions of software, there are important differences in exactly how we define these concepts and what are their priorities. Worse is better. Gabriel named the New Jersey approach because what he had in mind was chiefly Unix, which at the time was, I wouldn't say was starting, had already started and more or less succeeded in conquering the world of operating systems, of serious operating systems, and had, of course, been developed in New Jersey. In those terms, simplicity starts with simplicity of implementation, and only secondary interface, especially in the early Unix. Don't know if any of you has ever used Unix v7 or maybe even earlier. implementation was the fulcrum. It had to be simple to implement. Kernel put it this way: debugging is twice as hard as coding in the first place. So if you code to the complexity your mind can contain, you're definitely half as smart as you should be to ever debug it. That's one funny Kernel way of putting it. As for correctness, it's actually better to be simple, especially in implementation, than to be correct. It would be nice to have both, but if you can't have both, pick simple. As for consistency, the level that is demanded is not overly inconsistent. You may recall about that time when he won his Turing Prize, Ritchie and Thompson, forget which, I think it was Thompson, was asked if you had to design Unix all over again, what would you change? He said, I would spell create with an E. He had erroneously picked 4 letters for the system call names, old assembly language programmer. So he had spelled C-R-E-A-T, which is 5 letters, I know.
I heard that incorrectly. I just heard urban legend. I thought it was actually, I'd spell password correctly, and I see password C-P-S-S-W-D.
That's, we can check.
Oh no, that was actually someone else. That was probably.
As for completeness, it's the least important. The early versions of Unix definitely did not aim to cover the complete space of operating system. They targeted very precisely a certain range of mini computers. They did not, at the time, stretch up to mainframe, and it was essentially impossible to stretch them down to the very, by today's standards, underpowered PCs of the time. And trying to stretch in either way would have seriously threatened the core value of simplicity. And this is how University did things, and this is how Unix came about. The right thing of systems such as the ITSS and other operating systems, the possibly biggest of them, Multics, Unix was, in a sense, started and definitely named in reaction to the complications of Multics, and that's why Unix, because it's simpler than Multics. The core simplicity is that of interface. Doesn't matter how much blood, sweat, and tears go into the implementation, keep the interface simpler. The correctness is an absolute must, ideally feasible to formal language specification, to mathematical perfection. Consistency is just as important, and completeness, while not as important as consistency and correctness, is roughly as important as simplicity. So, how do we compare the two interpretation sets of the same 4 basic principle? Richard Gabriel, I think, put it best. The right thing philosophy is based on letting the expert do their expert thing all the way to the end before users get their hands on it. I'm quoting this word literally, but you can hear an echo get their dirty little grubby hands on it, right? Those users. Worse is better takes advantage of the natural advantages, yes, the repetition is in the original, of incremental development. Incremental improvement satisfies some human needs. Now, which one looks better at this point? Would you rather let the experts be experts up in their ivory towers without bothersome users around, or would you rather satisfy human needs? I like the way Chesterton put it. Anything worth doing, I don't know if you're at all familiar with Chesterton, he was an absolutely great author, especially his humor pieces were absolutely delightful. Anything worth doing is worth doing badly, which you could see as a invert always invert interpretation of the is worth doing right. As an example, I wish to point out that I often get criticized for allegedly using MS Comic Sans. Now, the title of this talk is not bad enough is good enough. It's rather good enough is good enough. And I admit that MS Comic Sans is bad. But this isn't. This is Apple chalkboard. If you can't tell the difference, I'm sorry for you, but take it up with Cupertino. Go tell them they don't have good visual designs. I'm sure they will listen carefully. While the debate in absolute terms between Richard Gabriel himself, but other people entered the fray on both sides too, was still going on, a few years later, my friend Eric Raymond published a collection of essays that he had mostly written and published previously, separately, with a completely different focus. He had in mind not so much design principles and things, but approaches to developing software. He later coined the term open source. Or stories differ. I've met people who swear he introduced the term and were there when he did, and he himself says, no, somebody else, but I don't know who mentioned it, and I just thought it sounded cool, and it would sell the concept. But by the time he was writing this, the term wasn't around yet, and so what he did was adopt the two models, the Cathedral model and the Bazaar model. The Cathedral model, in this interpretation, as opposed to the way cathedrals were actually built, which is Ken Follett has an absolutely incredible novel set. What's the title, Anna? I don't remember. Anyway, Ken Follett hasn't written that many books about cathedral buildings, so I'm sure you'll be able to locate it. Anyway, in this modelization, experts in charge is what Eric meant by the cathedral model. So it probably didn't have in mind so much the way a cathedral was built, rather, yes?
Pillars of the earth.
Pillars of the Earth, highly recommended fiction,
Yeah,
historical fiction. He didn't really have in mind the way a cathedral is built, but the way a cathedral is run. You know, the bishop is up there and he coordinates the priests, and the priests coordinate the faithful, pretty ordered and experts in charge. A bazaar, again, no matter how it's built, although it's probably also built in a somewhat haphazard way, but then it's definitely run in a very chaotic way. People, hawkers trying to call passers-by's attention, so others running them to look at this carpet and so on and so forth. So in the analogy to software development, it's definitely a launch and iterate, New Jersey-like model with a crowd in charge. So there's a lot of similarities between what Eric describes as Cathedral and Bazaar and what Gabriel had described as right thing versus better. But interestingly enough, while Gabriel hasn't really gone that deep in understanding what are the consequences, pluses and minuses, of the two models, Eric identified one which is almost orthogonal to what Gabriel had called out. His probably single most famous sentence in this book, given enough eyeballs, all bugs are shallow. So he's not really focusing on the features, he's focusing on the bugs. So you might not be interested because you could say, hey, I don't do bugs. You know? Well, I have to admit, my very first program was a hardware undergrad, freshman actually, and to pass even the hardware design of course, you had to take a Fortran course. Of course, every engineer has to know Fortran. It's a natural law, I think. And group of us who knew each other from before university because we played bridge, pretty serious for young kids, decided this was our occasion to get a printout of the table of conditional probability of suit division in contract bridge, which was like kind of hard to compute by hand with 4-function calculators. So of course, we took this crazy objective as our mandatory program to pass the course. Well, most people were printing Hello World or the equivalent. We had this rather more ambitious idea. And of course, everybody was saying, dudes, you can't do it. I mean, remember, the rules are you get one run. You punch your pack of cards, you put them in the reader when your button is pressed, and then you get the printout. And if the printout says syntax error, that's it. If you have any logical, well, we'll be very careful. And we were. Like, you know about pair programming. Well, that was like quad programming. The guy who was punching the cards watched over carefully for any typos, that level of thing. And before then, we had used coding forms and hashed out exactly what was to be done. So we got our one and only chance. It ran perfectly. And there's this, by now very yellowed, big bunch of computer print giving all the tables of suit probability divisions. And that was it for my life. That was the only program I ever wrote. Unfortunately, I didn't know you got exactly one chance at that in life, or much as I was interested in that, I wouldn't really have spent that one chance in this particular program, especially in an era of my life where I wasn't really interested in programming. I wanted to design integrated circuits, or learn to. Oh well, or maybe it's not one per lifetime, it's one per 40 years, in which case I'm soon due for the second flawless program. I'll be right. But it's probably better not to count on it. And why does the worse is better approach matter? They focus on simplicity, and simplicity of implementation is at least as important as the focus Eric identified, that you get many eyes. If you publish your source and it solves somebody's problem, it's of some interest, if there's something that doesn't really work right, you're not left all alone to do the debug. So, a big problem from my point of view is that aiming for perfection implies big design up front. I don't know if you're familiar with this acronym. Big design up front means I won't write a line of code until the whole detailed design is finished. I will not do any detailed design until the whole conceptual design and architecture are finished, and so on. If you want to only release perfect software, you need to have it all designed. From the start, everything must proceed top down. Perfect identification of requirements. You must know for sure exactly all that your users need to do. Perfect identification of requirements begets perfect architecture, division into subsystems and so on, which begets perfect design, which begets perfect implementation, and it takes forever and ever and ever. The problem and the reason proceeding differently satisfies some important human needs is that stakeholders, people who would like to be using your system, or if it's a commercial endeavor, would like to be selling your system, or selling whatever machine isn't useful without your system, and so on, tend to resent the forever part, which kind of implied Unix was no doubt better than, say, Multics, but it mostly grabbed market share because it was there. While the multics perfectionists were still hashing things out. There had been no release, and Unix was already in its version 7 and pretty snappy. You grab mindshare by being there. You don't by staying in your beautiful ivory tower and hashing out the perfect design in 7 times 7 years. I could say the same, why did C grab the world rather than say Ada? Is it so much better? Well, it's simpler. It's to some extent, it has some better aspects, but mostly it was there. You could actually run it on machines that were reasonably available at the time, while Ada, if you could get any at all, you'd need 3 mainframes to divide the load because it was so complicated. Or I could say Algol 68. There's been a lot of hugely complex programming languages, as well as operating systems, but probably more languages, because every programmer really wants to design their own programming language. So, while their own operating system is a less common endeavor, why doesn't big design up front work well, besides the fact that it takes forever? The main reason, the first reason, the reason that would kill the whole idea, even if all the others didn't apply, is that requirements change all the time. They're in most areas of human endeavor. If your program is about computing taxes, that's a good example, because there's never 1 year after the other where the exact rules and details of the tax laws stay the same. So you're never done catching requirements. You cannot possibly catch requirements perfectly, except in theory, for a vanishing small snapshot of time. Tantare, everything is changing all the time. So the requirements themselves are like shifting sands. And then you can't do all the architecture before you move on into the design, because a lot of design choices require you to alter the architecture to suit. It's not a top-down driven process by nature. And design varies with the implementation techniques you adopt. A lot of the time, I find myself with admittedly, I don't even try to design everything in total detail, but only realizing there's some ambiguous requirement that could be interpreted in different ways or hasn't been properly captured when time comes to actually implement it, because it's only when everything is gelled together, say, okay, exactly what formula should I use to compute this? And so that goes all the way back to the requirements and percolates again, and so on and so forth. Plus, except once every 40 years maybe, implementation has some bugs, and you will only discover some bugs when you actually hit the world. I mean, I'm a fanatic of testing. Testing is an absolute must, but it's not perfect. It's good enough, but it's not, and it will never be perfect. There will always be bugs that you haven't thought of, especially if you do unit testing the right way, in which essentially the same people are programming the tests and the implementation. If there's a misunderstanding in the team about some aspect, that will be reflected both in the way it's implemented and the way it's tested. It's only when users find out that the behavior had not been well understood that will happen in the real world. In some possibly early phase of friendly users. You'd better pick friendly users so they won't attack you bottom. So iterative development is really the only way real-world software development can proceed. You have to deploy something, and specifically what's sometimes called a minimum viable implementation, something that actually is some use. Somebody wants to use it. It must make their life better in some way they could not otherwise achieve, which gives them motivation to give your software an actual tryout. And then they will fix bugs, I can guarantee you, and that includes missing features. It's like, this is almost making my life better, but it's missing this key thing which you didn't realize was crucial, and so on. And then you improve and release again. But remember, it has to do something that's useful or delightful to somebody, because that's the only way you can win mindshare and get all this feedback. If your program is solving exactly the same set of problems as this other existing one, and the other existing one is more or less chugging along and you arrive second, and you don't do anything that's worth anybody's attention or time, well, some of your friends may humor you by trying it, but the first time they meet a bug or two, that's it. They can't keep wasting their time forever on it. So, when you're fixing bugs or making features work the way they should be, backwards incompatibility is your friend. If you are, by some freak of nature, it does happen, constrained to remain backwards compatible forever, your design errors from the early stages are going to be with you to the end of time. There are bunches of, that doesn't only apply to software, there's bunches of transistors, fortunately these days are cheap, in even the best and best designed Intel CPU, which needed to reproduce a very stupid design decision made around 1978, because that's one case where one of their selling point is that backward compatibility. You can take your assembly code and just reassemble it, and it will run on the latest chip. That's unfortunate, so try to work in sectors where backwards incompatibility is acceptable. Users will always complain if you move their cheese, they will complain, even if you can prove to an impartial judge that the new way of doing things is better than the old way of doing things. Harden your will, you will hear screams. But the point is that this is particularly important once you've given up on the big design up front, expert-driven thing, and so on, because good enough is good enough if and only if you can make it better as time goes. If you're constrained to keep doing things exactly the same way, well, I believe it was Einstein who defined doing exactly the same thing and expecting different results is the very definition of insanity. So you are going to go crazy if you find yourself fixed into backwards compatibility. One example of why introducing incompatibility does not kill you used to be, for example, in Python, that you could raise an arbitrary string. That was a bad design. Guido released before he had thought everything through, as he should have, because there were many other things, even in very early Python version, that were very good. This one was not. This one was a definite design mistake. So you now cannot raise anything but an exception. Some instance or class, which gets instantiated implicitly, of a subclass of exception. So if you raise something that is not an exception, you get a type error, because you're using the wrong type in that place. And this has happened for a few releases of Python since 2.6. Another way of looking at things, there's nothing wrong with perfect depending on how you pronounce it. Pronounce it as a verb, perfect, not as the adjective, perfect. Perfecting your work is absolutely great. It's exactly the iterative improvement we've been talking about all this time. You keep doing it. You keep, based on real data, real feedback from the field, making things better for everybody. Perfection is a process. It's not a state. You never reach it you're always asymptotically moving towards it. And the goalposts keep shifting. The real life requirements keep changing all the time. So don't worry about resting on your laurels. You will never have any laurels to rest on. They'll be moved together with the previously mentioned cheese. So, can you afford to skim on everything in order to get some software out there? No. Most things, yes. Not everything. Here's a few insights on stuff you should never, ever skip on. You need some form of lightweight, agile process, not just a total free-for-all chaos. Controlled chaos, if you will. For example, I hope nobody's ever thinking of doing any software development without revision control. If you're not a lone coder, that would be much better, you should always also do code reviews. I have a separate presentation on code reviews, maybe I should be giving again. And really, while I earlier mentioned that testing isn't perfect, it's really very good for you. And if you skimp on testing, you're not really saving time. It's being described as accumulating technical debt. Getting some debt is okay. You couldn't probably purchase a home without a mortgage, but then you studiously pay it back as much as possible because you definitely don't want it to balloon with the typical compound interest effect. Something many developers who've never actually been release engineers don't think of in the same class, but it definitely is proper release engineering practice. If somebody from the field, a user, indicates a bug, you need to be able to identify and reproduce exactly the bits that said user was running. So there needs to be an identifiable version number. Given the version number of the whole release, you must be able to trace back to the version of many components that went on to build it. And okay, this is what you need to be doing. And the whole discipline of release engineering is a series of recipes and procedures and principles for achieving this crucial goal of being able to reproduce exactly your user's bug. Also, you shouldn't, because it doesn't save you any time, it just accumulates huge amounts of critical technical debt, is skimp on code style. There's never any real advantage in being sloppy. Naming everything A, B, C, D, E, sure, you type only one character instead of 6 or 8 for a variable name, but then a couple days later you look back at that piece of code, it's like, okay, what does this variable do again? Give it a decent name. That's the simplest example, all the way to clarity and elegance. Also, unless it's absolutely totally obvious to anybody what all is your software is doing, which is really much less likely than you think, it should have some documentation. Otherwise, how are you going to gain users if they can't figure out, okay, this software promises to solve problems X, Y, and Z, which are driving me crazy. How do I do that? And they're supposed to figure it out by reverse engineering your code. Sorry, open source is a great idea, but don't take it as an excuse to say, oh, they just need to study my code and they'll see. No, they won't. You will really curtail the people who are not only able, but willing to do it, and it takes a lot of time. So that's one thing not to skimp on. A simpler way to remember all of this is to say no cowboy coding. That's a typical risk of the small or even a single individual group of very brilliant and usually very young and inexperienced guys. They think that's for old fuddy-duddy, I don't need it. Believe me, I've worked with incredible young geniuses. Actually, I keep doing that on a daily basis. Google is really rich in them, and it's not true, not even for them. So, specific things that must be in from the start, and I'm singling them out because they're absolutely crucial. Security. You do not design something without thinking of security, which, depending on what kind of data in particular your system needs to be holding, it may mean imply privacy, auditability, if it has anything to do with money, that kind of thing. Security in the sense of not letting a hacker take over or steal the identity of your user and so on. If you haven't designed it in, but after your beautiful program is starting to solve user needs, next you turn to, okay, now how do I make it secure? You've already lost. It's point is, the guy who's trying to break in is probably as smart as you, or even smarter, and more focused, because you're thinking of the whole system. They're only focusing on, okay, where are the vulnerabilities that let me exploit the system and steal data, or steal money, or somehow do damage. It's really harder to make something secure than it is to break insufficient security. If the security is not designed in from the start, you've lost, no matter how well you work on it afterwards. Many other things that are not really about security, you'd rather have them in from the start, but there is no necessarily any adversary that puts you in this disadvantaged position as you are when you don't have the security. You can refactor, probably should continuously refactor your code. For example, I've been a big paladin and evangelist of APIs, how important it is to expose an API. But if you don't have it at the start, that's not a killer. If your program originally can only be used interactively, and then you start thinking, okay, now how do I let other program mash it up and use it, that's okay, you can do it. It's more work in the end, but it's work that lets you deliver something and start solving users' problems first, and then solve more problems later. Scalability. We want every program, hey, if now my website goes to 1 billion users tomorrow, how do I do that? Well, it's a problem we all wish to have. Sure, it's easier if you can design it in from the start, but that's not necessarily feasible. And sometimes you can say, okay, I know this algorithm is order of n squared, so it would be fine for 100 users, but if I get 1 million users, the whole thing will crash. Well, I know there are order of n algorithms for that, but they're very complicated to program. Like, well, let me give you one example of this. Early versions of Python, all the way to, I believe, 1.6, or even possibly maybe even to 0, had the most stupid multiplication routine you could possibly imagine. They multiplied two integers of unbound size, the long type, by a n order of n times m process, where n and m are the number of digits in the two numbers, exactly as you would do with pencil and paper, which is, of course, absolutely ridiculous. There are known algorithms that are for numbers with a few billion digits, doing it in the way Python did it in 1995 would take a year on the most powerful computer, and we know algorithms that get it done in 10 minutes. Of course, problem is that writing a correct multiplication algorithm with the simple, the first grade arithmetic takes, I don't know, 100 lines of C and 1 day to write and test very thoroughly. Karatsuba, which is a relatively simple algorithm that does better, could take 10 times as much code and 20 times as much time to code and debug. The really strong algorithms, the ones which really scale to billion of digits, we're talking about 100 times more code and 1,000 times more time to debug. Should Guido have spent 10 years designing and perfecting a multiplication algorithm? What about all the rest of the language? He did the right thing. He ignored scalability, which would have cost too much. Very few people in the early, probably nobody in the early days, well, Python was limited to 32 bits, so it couldn't address the billion of digits that would absolutely blow it up. Of course, even with 1 million digits, it wouldn't have been all that fast. That's why one of the reasons I implemented GMPY, the general multi-precision for Python add-on, was to actually access really fast multiplication algorithms. These days, it has many other things that you can use, all sort of numerical analysis, Jacobi's, Legendre, and so on. But for the multiplication, the advantages remaining compared to Python, where really strong multiplication algorithms have been by now implemented, not the billion digits one, but you're going to do very well for several million digits numbers. So scalability can be retrofitted. Scalability, the typical example, not using an order of n squared algorithm where an order of n log n one exists, is a clear example of making things scalable. And sometimes it's better to incur technical debt. Technical debt, like that in general, is not necessarily bad. Almost every company incurs some debt. Even those who might not need to, like Google, Apple, Microsoft, they gush a lot of cash, they still float bonds, because that gives them more money to invest or to return to shareholders. Look it up, they all have bonds out, even though you might think they don't need that. Not need, but it gives them leverage. So of course, they do it. And similarly, you can incur technical debt. You just need to know when and where. It's an important and difficult judgment problem. One way of thinking about it is the problem recoverable or not? Like, what's in common between the two categories? The things I identified as you must have them from the start, and the things I said, don't worry, you can do without at first, incur technical debt, pay it back later, refactor later. Whether the problem they cause, that taking the shortcut cause, are or not recoverable. If your security is broken or non-existent, that's not recoverable. Once a user's personal secret data are out, there's no way you can wipe them away from the hacker's mind and back into hiding. It's an irrecoverable problem. Most problems are recoverable. So, when you're thinking of a potential error, potential weakness due to a shortcut, and so on, think about it. Could this cause irrecoverable losses? Losses that in practice, and maybe even in theory, can never be made whole again. So, can it kill somebody? Can it leak secrets, which, while not quite as bad as killing, depending on the nature of the secret, might almost become equivalent? Think of a coercive government somewhere who gets away to find out the identities of people using your software to post criticisms. That if you let that data out, you've killed those people. So that is not recoverable. So that is the kind of thing that you should never skimp on. Most of the time, an error which can be practically recovered, as long as you carefully tag your software beta while it still may have those errors, is kind of okay. People will, also in the open source world, but mostly I think in commercial endeavors, worry a lot about reputational damage. They say, yeah, the errors can be fixed, the damage can be recovered, but my reputation is smeared forever. The point is, it's easy to convince yourself of that because we all have a certain amount of pride. And looking silly, stupid, not a easy prospect to face. But if you look at it objectively, usually, yes, you usually can repair reputational damage, as long as you respond with courtesy and speed to the issues that get reported. It's usually okay to get it right the second time. Of course, you can easily, okay, you have a problem, a user finds it out and points it out, maybe with less than optimal courtesy, they're irritated or something, and you react rudely or get into denial, insult the user himself, that can easily destroy your reputation. But the error per se, as long as you accept it, grateful to the user that has discovered it and bend over backward to fix it, rapidly and courteously, doesn't necessarily damage you even. There's somewhat controversial, but not really secret, in the world of customer service. It's known as the service recovery paradox. Customers with the highest level of satisfaction tend to be those who have experienced a problem but had it resolved satisfactorily. One of the crucial studies here was about one of the case studies in the book was about, I think, hotels. There are, of course, plenty of times where you stay at a hotel and there is absolutely no problem whatsoever, and that's fine, you're happy. But if there is a problem and it gets, you call down someone irritated at the front desk and they fix it immediately, I mean, the person is, the room service or whatever, is there like apologizing, giving you extra towels and so on and so forth. In retrospect, you remember that hotel as particularly nice and helpful, even more than the ones who already had plenty of towels and other problems like that. I do not recommend, it's somewhat controversial, so I do not recommend deliberately putting in bugs that your user will find out, so you can fix them incredibly fast because you already know where they're. It may be worth a try. I am sometimes tempted to. It's similar to the old idea that you should have one obvious typo and maybe one dubious grammar use when you hand in an essay in school, because the teacher will not be happy unless they can find at least one or two errors. So make sure they can easily find those and they will not dig as deeply as the point. It's controversial, I'm not saying it necessarily works, depends on the teacher. Another thing people are often convinced of is that a ad hoc solution will save them time and then maybe they can refactor it later. It may, but more often than not, a general solution is actually less work. Let me just give this one example. You have some kind of tree or forest, and you want to find by an attribute, for example, the color, whatever that is. So you write find by color. I would name it find by color, but I needed to fit it in the slides. That's why I've strange abbreviated with this find by call, which is the obvious recursive implementation. And then you find, you also need to find by shape, and then you essentially copy and edit exactly the same code, because that will save you time. And if this keeps happening with different attributes, more likely than not, you are really shooting yourself in the foot. As soon as you see the repetition, take it away. Don't repeat yourself. It doesn't really save you any time. I could say, don't repeat yourself, but that would be kind of self-fulfilling. So you just do a more general find, which in this case uses introspection with get after. And then if you want to call the function find by color and find by shape and so on, they just will do one call to find with the appropriate attribute name. Just, it's not necessarily true, but just because I keep essentially pushing towards cutting corners, including that, remember that some corners are easier and faster not to cut. Depends on the language, of course. I don't even want to think how much work it would be to get the same kind of generality in, say, Java. But in Python, yeah. So, let's give some example. Some from programming, some from other areas of life. For example, one thing we've settled for is giving up this great advantage still enjoyed by many of our colleagues who work in C++ or Java, the natural breaks where the code is compiling and linking. So, of course, your boss can't really get angry if you take the break, because there's nothing you can do. That's getting less and less true as a compile and link is probably happening on a cloud of dedicated servers anyway, but we gave that up long ago in favor of our advantages.
Right.
But,
Integration testing.
Mm-hmm. Yeah. If you need to wait for integration testing to complete, yeah. MapReduce is also a good one. Depends on the scale, but you're on the. It's quite easy. You have enough terabytes of data, no matter how many machines. You do have to take a break. My favorite example is networking stacks. TCP/IP was essentially clobbered together by geniuses, absolute geniuses, but a ragtag band who had different ideas of what should work and how and so on, especially as you toward the extremes where different implementation, different hardware bits and pieces have different requirements, so very low levels, and at the top level and so on, the thing are really a mixed bag. They also International Standard Organization Open System Implementation, but I think they liked the palindromic nature of the thing, so they came up with that later. It was like hundreds, if not thousands, of experts doing their expert thing, in interminable years in committee rooms, so long essays back to each other to design the perfect stack. While the TCP/IP unruly crowd was working on what one of them named as a core principle, rough consensus and running code. Interestingly enough, the guy who did come up with this incredibly strong and good soundbite, David Clark, was actually from MIT and had worked on the ITSS right thing approach, but obviously he had learned something from that experience. Was one of the early bright lights are in a room full of incredibly bright people at the Internet Engineering Task Force. So, guess which one conquered the world? Yeah, my daughter just got her PhD in telecommunication engineering, and he said, oh yeah, there is a couple of courses, like one at the bachelor level, one at the master level, to give us the terminology and so on, which do mention the ISOs stack, but then you start doing real work, it's IP all the way. It's like, except for some legacy piece of grad, IP has completely won the battle and taken over the world. People are now only debating things like IP over what? Like the lowest layers of the transport, what's supposed to happen. But let's focus on an example at the upper layer. Anybody ever heard of Xanadu? Yeah. Some of us old-timers are around. That was an incredible visionary program that they, I believe, the original design for computer lib, the text where the guy pronounced it. That would be the perfect hypertext. Think of what you need from a hypertext. For example, it's ridiculous that links go to a point. They obviously should go to a range, right? As in, so here I'm quoting from here to there. You don't necessarily want to quote a whole document, you typically don't, or just a spot. You want to quote a range. And the links should be bidirectional. It should be trivial to find out who all is quoting this, is pointing to this, and so on and so forth. I mean, read the book. It's really after Vannevar Bush, very early as we may think, decades later, the very birth of hypertext as a living idea. Unfortunately, that's what it remained, because Nelson didn't want to release anything that wouldn't be perfect. Project Xanadu fired up so much enthusiasm, got plenty of funding, hired brilliant people, and never released working code. At the same time, chemical physicist or physical chemist, I believe, of British descent working in Switzerland, really needed a way to publish scientific papers today, so he hacked up something and ambitiously called it the World Wide Web. Seriously weak transport protocol, a markup language that not even a mother could love. Seriously, look at the pre-1.0 HTML, HTTP, and so on. Guess which one conquered the world?
Although in an era in which computing and networking was substantially cheaper than the era in which Xanadu was, like there's a time difference there, and there's a right time.
Oh yeah, there is that too. But
not a major confound.
A sufficiently slimmed down system of linked hypertext could have been released roughly at the time in which, for example, French Minitel was all the rage. It is several years before. Remember, Minitel ran on incredibly simplified, so presumably no graphics and so on. But I think rendering graphics was very costly in the 70s. Text already wasn't. Modem of the era could do a perfectly reasonable job of sending text. So the user program, which is not responsible for the interrupt, must never need to know and take any precautions against that interrupt. So every system call, incidentally, thousands of lines of assembly code, but must be able to undo any state changes up to the point where the interrupt arrives, resume user mode to do the interrupt service, and then restart kernel mode and rebuild all the state. Every single long-running interruptible system call. Result, simplicity for the user, Yeah, nice. The user doesn't need to know interrupts happen. Absolute hell for the programmers. Absolute, just imagine writing a device driver that must be able to unwind, resume, restart at any time. The Unix solution, early Unix. If an interrupt happens, you set the global variable error. That was a global back at the time. They became a state thing much later. And you return -1, which means there was an error. Try again. So, this is simplicity of implementation. Of course, it's not simplicity of interface. Now, the user, anytime they make a system call, must be aware that it can be interrupted without no fault of their own, and they must do this. It's a simple while loop. It's not. You've added 3 lines of code to every user program making a system call. You've saved 30,000 lines of assembly code in the most complicated and delicate parts of your system. That's the difference between.
So if the Unix approach requires 3 lines of code in every program to handle it,
very formulaic.
then it seemed to me it would be, the IPS could also have implemented it where, okay, they have the wrapper between the system call and the user program, they put the 3 lines of code there for every program, much like the generic thing you just did with color and shape.
Say, for example, that the system is being asked to fill a buffer supplied by the user. Now, the size of that buffer need not be constrained. The kernel cannot allocate a constrained amount of memory to keep a security copy. The user can, of course, if they need that data to be atomic, so to speak, pseudo-atomic, quasi-atomic. There's people who have not programmed kernels tend to think, oh, kernel mode, that's only powerful. No, it has very different powers, but also very different constraints from user land. With great power came great responsibility. So no, those lines in kernel mode would not have worked.
But then that wouldn't be this case. That's a case. It's not an interrupt case. That's a case where, like, you're reading a file and you exceed your buffer length, and so it's part of the interface that, okay, you can only.
No, you get an interrupt in the middle of reading the file. Now, the file is, say, a tape. You can, or not, choose to rewind to the start, but you probably lost the exit position. So, at a user level, not. You start reading from the start. At a kernel level, not necessarily. Where are all those pages mapped?
So, okay, so in this case, it'd be different 3 lines of code, because you have to rewind the tape so that you can start reading it again.
Right. And where's all those those pages mapped?
Yeah.
Still, although not quite as crystal simple, Berkeley Unix eventually found a way, originally based on a particularly clever hack in virtual memory implementation, but it's a very long story, and I very much doubt a majority of the audience understands enough about kernel level programming to be that much interested. Still, Berkeley Unix found a way to mostly avoid this for many system calls, not all. Python examples at last. All the people were I saw the pitchforks were starting to mention Python or well. An example, a rare example, where Python tried to use the right thing approach was when he introduced metaclasses. He had just read a very fascinating book by a group of ex-colleagues of mine at IBM Research what designed this essentially C++ variant kern about the system object model, SOM, of IBM, unfortunately implemented only in the unfortunate OS2, but it was not a bad model at all. And the whole language centered about, and it's really an enthusiasm-making book if you're a programming language enthusiast. And so he studied what it would mean in Python and introduced metaclasses, which are infinitely powerful and proportionately complex. They're very much the right thing. People who understood and properly used metaclasses in the first year or two, they were out, could be counted on the fingers of a couple hands at most. I know because I had to fix so many of those. And of course, it was a new toy and a serious powerful thing, so people were also using it where it wasn't warranted because there was no obvious other way to do it. And then, long later, decorators were finally extended from functions to classes with exactly the same semantics. It is a decorator is a function that takes the class object as an argument and returns the class object as a result, or any object, always the class object. So the same task of silly task in this particular case, I needed to fit it on one slide, make sure this class has a foo argument that is set to bar, is done in a much simpler way. This doesn't let you do everything the way metaclasses do, but Pareto principle applies. 80% of the benefit comes from 20% of the effort. Much more often, Python has done incremental improvement, and that's why it gained so much mind share and eventually grew to become so powerful. Sorting once was absolutely, apart from in the internals, it was a quicker sort, nothing special. The only way you could customize a sort was by passing a comparison function, which, as it was easy to forget, needed to return -1, 0, or 1. And not cold, n log n times, order of n log n times. It was always in place, relatively slow, especially in worst cases, because quicker sort is vulnerable to those, cumbersome to writing. Then came DSU, the idiom I introduced, actually stole from Perl, to build an intermediate list with a decorated K of A items. So you can now sort naturally without a comparison function, because you're implicitly comparing on the first item. And then, if you don't want it in place, you can set it as a, if you do want it in place, you can set a new sorted list. Actually, no, you need to undecorate. So not assigning X, but assigning Y of 0 for Y of 1 for Y. And then Raymond Hettinger took my idea and essentially put it in the, yes?
Just a quick question. Is this the decorate, sort, undecorate?
Correct.
Okay.
And that's now the way sort works, is by applying DSU internally. If you pass it a key function instead of a comparison function, it extracts all the keys, but only once each. So it's O of n times of call to the key function instead of n log n to the comparison function. And of course, there's also a sorted, which isn't in place, but generates a new list. And the internal algorithm is now Tim sort, which is natural merge sort with all of Tim Peters' magic. But there's been many steps, incremental improvement steps to go there, and the original sort was written very fast and hit the road and worked in quite well enough in many cases. Similar generators once were yield only. They were called simple generators because of that, and now you can send stuff into them, which so that yield can receive something, not just yield it. finalization once, and you can still use it if you need it, obtained with try finally and with all this sort of exception. By the way, they were not working inside generators, so the last 2 points are mixed, and now the with statement, which gives you the best form ever of resource allocation is initialization. And now, for some non-programming examples, I had to censor XKCD to make sure I'm not violating any code of conduct. But XKCD can use the word, the F word. This is the title of an essay I actually read on a LinkedIn page from Eric Ries. You may know his Lean Startups book. It's very good if you're into startups, and even if you aren't really, because there's a lot of things even a big established company need, at least in this valley, to stay startup-like. Essentially, his middle way it identifies the MVP, the minimum viable product, and focuses very much on the selfish advantages of the learning it affords to the team. I wish he pointed out more that there must be a flip side. I mean, it must be solving some problems the user couldn't easily solve otherwise their motivation is just not there. 37 Signals, I must mention, disagrees in a comment. I mean, Hansen disagrees. Just build something awesome and ship it, and I believe if you are, Hansen is probably right. It's like calibrating the exact amount of function. Just be awesome all the time. This is, I should point out, very much personal statement, and I wish my employer adopted it. But lot of places, especially startups, are absolutely out for the perfect template. If you're in such a hiring situation, think again. Read the blog a bit. It will take months, and if you're hiring, especially in a constrained startup, it means you desperately need that one person. They should be there, sitting in your office or working from home, or however you're arranging things, producing results, not all your people spending uncountable hours in the course of months interviewing, and so you get a negative amount of extra strength in your team instead of a positive. The person, assuming there is a person that's perfect there, they might not be looking. If they're that good, they probably have a wonderful job. Indeed, they may have such a good job that if you identified the person, you probably couldn't afford them. If you're a resource-constrained startup, I mean, they must be making a lot of money. What I'm referring to is a startup that explains, for example, that they use these 29 technologies, and what they want to hire is somebody who's a world-class expert at each of the 29. Good luck. What you should be doing is pick a good fit, not a perfect fit. Good enough is good enough. You must focus on unrecoverable errors. That's my terminology, but it fits the message that this undercover recruiter is sending. There are things that you cannot give up on, and that's essentially personality and culture match. You cannot afford to hire somebody who may even be perfect in other respects, but is an asshole. Oops, well, I didn't. You cannot. That would destroy you. That is unrecoverable, or it can easily happen. What you want is somebody who's got the right personality to fit with the team, somebody who's a great cultural match for where you are and you want to be, and somebody who loves learning new things, because even if he did already know all the stuff you're using now, well, let me reveal a secret. A year from now, there will be a lot of changes in your tool set, because this is Silicon Valley, dudes. We're like changing all the time. You have to run for all your worth to stay in the same place. And so provide training on this skill. That's a much better investment. Most stuff they can probably actually learn on their own if they're one aspect of personality and culture, avid to learn new stuff as opposed, oh, I don't need to learn another source code control system. CVS was good enough for me. It's good enough for me. Okay, well, maybe that's not the right personality and culture match, but that, you see what I mean. Good enough is good enough. Also applies to stuff that, okay, I'm a software developer, but this recruiter is not necessarily talking about software development. He's general irretrievable sort of firms. And this applies whether you're selling shoes or writing software, or rather trying to hire a person to. And then there's a interesting way in which a good enough concept meshes with a satisfizer versus maximizer concept. I don't know if you're familiar with it. A great way to learn is Barry Schwartz, The Paradox of Choice, Why Less is More. It's a book on merchandising, essentially. The part of marketing that deals with a choice and arrangement of physical, mostly physical merchandise in a store. So you may, or a supermarket, you may wonder, why would I care? Well, you probably shop sometimes, so merchandising influences you indirectly. But the point is, it's easier to think only of one potential shopper in your store, the maximizer. The maximizer lives by the rule that 99.99% is not 100, so it's a total failure. The satisficer, which is actually the majority of the population, goes like, 90% is swell, take it. Hey, 80% is probably good enough. 20% of a Ford, remember Pareto's law, 20% of a Ford produces 80% of the result. And this is the shopper who's you're going to lose if you have 4,000 SKUs of cereal out there in your supermarket, because they're going to give up. They don't care to find the perfect cereal. They want something that's good enough. Well, you need some choice, but too much choice actually works against you because it works against the vast majority of your potential customers. One example from history. Have you heard of the Gettysburg dedication? Not address. Everybody's heard of the Gettysburg Address. Have you heard of the Gettysburg dedication? One person, two people. Do you recognize this guy?
Is that important? It was the guy who talked before Lincoln for like an hour and a half.
Fantastic. You're ahead of me. So yeah, Edward Everett, a great civil servant, founder of universities, a professor, dean, governor of Massachusetts. It's like he did a lot of stuff. He was the most famous orator of his day. So to celebrate and commemorate the decision of dedicating a part of the Gettysburg battlefield as a cemetery, he was tasked to write a proper oration, a proper dedication. And it came out, we have a careful historical record, at 35,508 words. A couple of hours, and substantial ream of handwritten, of course, given the time, paper. Apparently, at the time, he had a lot of success. When the applause died down, the president, who wasn't sure he could make it, but finally was able to, stepped out on the podium. According to at least some reliable witnesses, but historians are in a bit of disagreement with that, he said to pulled out a crumpled envelope from his capacious pockets in his writing note, glanced at it and put it back away again. That doesn't mean anything, but I think,
Well, I think actually, if you listen to a lot of historians, they probably spend a lot more time working on those 267 words than Edward Everett.
that is possible, but I think it's more likely he wrote it on the train. He was pretty busy
Yeah, busy dude.
in Washington.
There's a minimum time to write 13,000 words down. Like it just takes some time to write all that out. Lincoln's busy.
Yeah, and they're very carefully chosen and polished words. You can find it in the public domain, of course.
And he didn't even have a word processor.
That's correct. So anyway, the back of the envelope is uncertain, but I don't think anybody's claiming that envelope had, 267 words don't really fit in the back of the envelope. But probably the high points, just to remind himself what he really wanted to do. So anyway,
Well, if you're going to use history, then you have to account for Thomas Jefferson, who famously wrote to a friend, "I would have written you a shorter letter, but I didn't have time."
I would happily do so, but I doubt Jefferson, who was really fanatic about French history, would have stolen the words from Blaise Pascal without giving credit. This sentence has been attributed typically a lot of time to Mark Twain, who would have happily stolen he was very much there before his time in the famous Pablo Picasso quote, "Good artists copy, great artists steal." Which, anyway. So I would point out, however, there was a wrong idea among those because just about every school kid in America today does memorize, at least it used to be. I don't know if that's still true. Still, you can hardly say he was right about the little note and long remember. So we're almost done. I would like to make sure the purpose of this whole talk was done, because it might be taken as, okay, so we should just lower our expectations, set ourselves more irretrievable. Well, that would be the totally wrong way to listen to a lot of time spent talking. Our dreams must stay big. Big, hairy, audacious goals. That's really, really important to get anything useful done. Or, as a poet put in the mouth of a painter, trying hard to come across as to why the formal perfection was not what it was after. Rightly traced in what order, what of that? Speak as they please. What do the mountain care? It's very neatly lines. I mean, I had a longer quote in the summary that's been nailed. The point is not to lower your ambitions and lower your dreams. Is to set your sight to the stars, but realize that to get there, the best way to get there. So I'm not saying change the destination, I'm saying change the itinerary to that destination, move through release early, release often, learn from interactions of real users. No matter how good you are at requirement catching, no matter how good you are at getting into your user's mind, you're not as good as they are. They're already in their minds. So give them the flipping beta release. Watch them play with it. But a man's reach should exceed his grasp, or what's a heaven for? This is the ending of the same piece of poem I was quoting there. It's Browning's Andrea del Sarto. And by the way, if you've noticed the subtitle of Barry Schwartz, Why Less is More, the phrase less is more, as far as I can tell, was put in print in English the first time as part of Browning's Andrea del Sarto poem. He was specifically explaining why didn't he carefully and accurately do all the details in the background, but slightly fuzzed it, which was indeed somewhat a revolutionary idea in real painting in the Renaissance. Although it might have been inspired by frescoes. Frescoes, as you may be aware of, are painted on plaster as it is dry, so it comes with a built-in deadline. Once the plaster is dry, no more color. So therefore, you have to kind of blur and oversimplify the non-important parts so you can focus on the important parts. Next time you visit Europe, presumably, and look at frescoes, keep that in mind, because it's an interesting technical detail of why even those from the Middle Ages already look somewhat modern in a sense, because the concept might have come from there. Del Sarto wasn't doing frescoes though. He was doing regular paintings, so he could have, like all of his predecessors, taken just as much time per square millimeter to make everything perfect. He didn't want to, maybe inspired by the frescoes, at least so some say art historians, browning things a bit as a stroke of genius or of heart. It's like, I want the people to look at the Madonna's face, not at the crowds in the background. So the crowds are good enough as just a vague hint, so it's obvious there's a lot of people there, but the details don't matter. They rightly tracing and well ordering everything would actually distract from the part of the picture I want people's heart in, because a mountain wouldn't care. I want the mountain to care. And this is what I hope you can achieve in your own art. And that's, it's a bit late, but we may still have a little time for Q&A.